Welcome back again. Today we are going to discuss, I think, from chapter 4 onward, from the topics of statistical software are, and we are going to see or discuss some topics from the book of by Gardner. So I think we have done chapter 4 or what? Do you remember anything? Hello. Hello. Am I audible? Hello.
Yes, sir. Hello.
Could you please answer my question, whether or not we have discussed this chapter number 4? Have you seen this str command, structure command? No?
No, sir.
Okay. So how much we covered? Chapter 3 we covered. These are the fetching data or extracting data from a matrix or what we called data frame. This we have done, sorting and all.
Yes, sir.
Yes, sir.
We have done this. We have done this, I think. Cbind command and all these things we have. We are converting a matrix to data frame. This we have done.
Yes, sir.
Just say me yes or no quickly. This you know that how to make data frame, no? So you have some vectors, then we can keep them in item 1, item 2, item 3, and we can write data.frame. Then we will be creating a data frame. Okay. Cbind converting matrix to data frame and converting data frame into matrix. We remember these things. Everything gone, I think. Don't know anything, huh? Okay, let us start from here. So if you have some matrix, MAT matrix is there. I think this is chapter 3. Okay. Chapter 3. In chapter 3, okay, let us start from here. So you see MAT is you can see this is a matrix. All right. This is a matrix, and there are 2 columns. Okay. So if you want to change this matrix into a data frame, we can use this command as data, this command, like, okay. Let me copy it. We are changing one thing to another thing. So mat is a matrix. I want to change it into data frame. So now it has been changed to data frame. So mat to frame. So if you want to know the class of this, you can see mat to frame, FRAM. Okay, ME. And you see this is a data frame. And if you want to know the class of MAT, you just sorry, MAT. So you see this is a matrix or array. All right. So matrix we change to data frame. And if you want to change a data frame to matrix, you can do by using this as dot matrix. Okay, so grass is a data frame. Like grass is a data frame. let us write MAT, and in MAT we are saving. We are saving a new matrix. We have a data frame named what is called GRAS2. GRAS2 is a data frame, and I want to change it to a matrix. So we need to write as dot matrix. This is the kind of object we want to save. Okay, in which we want to save, we want to convert. Okay, so this is as dot matrix. So we want to convert into matrix. Here you see as dot data frame, as dot and then data frame, because you know that how we create data frame, we write command data dot frame. Okay, so here you see where we have created sometime before data frame, like here data dot frame. So this is used to create a data frame, data dot frame. For matrix, to create matrix, we used to write matrix. Okay, so if you want to create a data frame, we change a data frame to matrix, we need to write as dot matrix. If you want to change matrix to data frame, so we need to write as dot data dot frame. Okay, so here, if you want to change data frame grass to a matrix, so we need to write as dot matrix. Okay, and then in parenthesis, we need to write the object. The object was this grass. So now if you want to see, you can see, you can check the class of mat1. Okay, I think, yeah, one here spelling mistake. You see now, earlier grass was a data frame, now it has been converted to a matrix. So in this way, we can change data frame to matrix, matrix to data frame. And if you want to change a data frame into a list, so you need to write simply as dot list, and the data frame, and then a name of data frame in parentheses. All right. Like just like we had earlier, grass as matrix here. Sorry, grass as data frame. Okay, so we changed it into a matrix. So if you want to change it in list, so let us write list1. In this, we want to save as dot list list, and now you can write the name of data frame. FW was also a data frame. Okay, so we changed it. Okay, so FW was data frame, we changed it to a list. So you want to see the class here, write list one, then press enter. So now it has been converted to a list. Okay. So convert matrix into a list. So in matrix into a list, if you want to convert, so first you have to convert this matrix. This YR dot matrix is a matrix. Then you need to convert it into data frame. Then you have to convert into a list. Okay. So if you want to convert something into a list, then you need to convert list into a data frame, and then you can convert into matrix or something. Okay. Converting list, you are converting this into a list. So in this way you can convert. So these are the some command you can think of. So these are the some suggested or exercise problem, and there are summary what you have learned: rank, order, and class, and then converting a data frame to list, list to data frame to matrix, matrix to data frame, like convert matrix into data frame like this. Okay, so many things we have, and these are the summary, summary of commands what we have learned in this chapter. Okay, so let us move to chapter number 4. In chapter number 4, there are some part related to statistical analysis. But in this chapter, we are not going to get any statistical parameter. Okay. Only we will be seeing some structure kind of thing. So one thing that if you have some object, we can apply this str command. So this will produce a structure. Okay. In structure, this will give the type of the data. That is, this is a data frame, the type of object. So this is a data frame. Okay. 9 observation, 2 variables, and there are the two variables has these kind of one is integer, another is factor. Okay. In factor, we have 2 levels. So if you want to see, use this, you can str, and then suppose I want the structure of grass, and grass is, you know, that is a data frame. So here, did 9 observation, 2 variables. There there is one vector, one column named rich, which has values as integers. Okay, and another column is grays, in which there are 2 levels. Levels means there are more and unmore. So there it is counting. Okay, it is counting. You can see here grass. Then you can relate. Okay, here this is a grass. It has 2 columns. So one grays and another is grays. Okay. So this simply produces a summary kind of thing. Okay, so we have this these things. And then maximum, minimum, length, sum, mean, median, and standard deviation. These are the command you can use, and you can find it out. Okay. So this command produces single value for summary statistics command for explanation. Like if you have some vector x, then we can find minimum, we can find a length. Okay. So to avoid if there is some like NA, so we used to write NA is equals to false. Okay. So if you want to NA.rm is false. That is, if you want to remove it, if you write false, then it will not produce anything. Like you see, there is a there are some, I think FW, no, not FW, but today I have shared something. I think what was I think data 2. In data 2, any was or what? No, this is an integer. They are integer only. What was that? There was an unmo, I think. Yeah, unmo. There was unmo vector, unmo. Okay. So unmo, this is a vector. You see there is NA. Okay. So if I write maximum, I want to find the maximum of this unmo. What we are going to get? We are going to NA, get NA. So I need to tell this that RM dot NA. So if I want to remove, then remove NA. Yeah. So if I say yes, true. Suppose you are asking remove NA to me. If I say yes, it means I'm saying true, T. That is true. Yes, remove it. So I will be getting some. Yeah. NA.rm equals to, yeah, true. Okay. Yeah, NA.rm dot NA NA.rm. This by mistake. NA.rm. Okay, like this. NA.rm. So NA, that is this one. I'm asking NA should be removed or what? So if I say yes, that is true, then I will be getting something. It will ignore NA, this NA, and it will compute. Okay. And if I say that no, this is I don't want to remove. If I write false or capital F, then I will be getting NA. So wherever you are having NA in some matrix or in some what we call data frame or in some vector, then finally we are going to get NA only, unless I write here true. Okay, so it will ignore NA and then it will compute. Okay. So like standard deviation also. Okay. If I want to find for standard deviation of data 2, so data 2 is a numeric data, so I will be getting something. So there is nothing to write like this. Even if I'm writing it here, because there is no NA, so I will be getting the same result, whether I am writing true or I'm writing false. Okay, so I will be getting same result. But if we don't know whether there is NA or not, so it is better to use this. Okay, NA.rm equals to T. That is true. Fine. So all these commands, if you write length X, so it will compute the length X. Okay, and this will include NA also. Okay, so here this instruction is not required. This is will find variance, standard deviation, median, mean, and this is median. Okay, there are two commands. One is show median of the vector, and then this MAD command will compute median absolute deviation. Okay, so you should remember the difference between these two. Okay, and then we have a 5-number summary command, 5num of data and after data name. Okay, so the summary command, I think I have told you already. So if I want to summary command of FW is a data frame. You can use here a matrix also. You can write here matrix or vector, whatever you feel like. So you can generate the summary for it. Okay. So in summary, you will be getting a few things, namely 6 things: minimum, maximum, first quantile, third quantile, median, and mean. Okay. And if you want to know only 5 things, so 5, you have to write 5 NUM. So this will generate 5-number summary of, for example, FW. So you see 5 num, just a minute, 5 NUM. 5 NEM. What is this writing? Error data frame X order. Okay. So, okay. So 5-number summary. This is actually 5-number summary is calculated for a what we call a vector. Okay. But summary command will work for every, whether it is a data frame, whether it is matrix or it is a list. Okay, so a summary command will work for everything. But if you want to calculate 5-number summary, then you have to use a vector. So here, just like that, data dot name is a vector in which these are the entries, and then 5-number summary you are getting maximum, minimum, first, median, and something. I think 3 to 3 commands. One here in summary we get 6 parameters. In 5-number summary we get only, like here we get only 5 parameters, like you see. And then if you want summary for data 2, so let us see. So you see 2 is here, minimum is here, minimum is here, maximum is here, maximum is here. So in the summary, you get the name of parameters also, but in 5-number summary, we get only digits. Okay, and then 3.5, this one, 3.5 is there, then 5.0 is there, 5.0 is median. Okay, median we are getting, and then 6.5 is what? I think this third quantile, and the 3.5, it is, I think, truncating. Okay, so 3.5 is first quantile, median. And here 5.0 is, I think, median is there. Okay, it is not calculating yet.
So it calculates mean. It's not calculating median.
Yeah. But it is not becoming clear here with this example. I don't know why. Okay. So then if you want to calculate quantile for a vector, okay, so we need to write quantile and then x, fine. So here in this exercise or this task, if we have for example data 2 and I want to calculate 20% quantile, then I need to write quantile and then the name of data, and then if I'm to 20%, so we need to write 0.2. So it will calculate it just like 3. If I want to calculate for more percentage, so like 20%, 50%, 80%. So I need to create a vector here like this. So 0.2, 0.5, and 0.8. Okay, so it will write 20%, 50%, and 80%, and it will give the result below this. Okay, so here in this 50%, 75%, and 25%. Whatever you desire, you can calculate the quantile of that particular percentage. Okay, so here 20%, 50%, and 80%. So here names equals to f. It means that this percentage is not going to be displayed. Okay, so here 5357 is there, but the percentage is not there. Just like here we have 50, 75, and 25%. So like the data, suppose we have unmo and there are 2 Na is there. Okay, 2 Na are there. So if I write here quantile of unmo, then we will be getting some error. Okay, so for that we can write na.rm equals to t. So it will ignore these Na and then it will calculate. Okay. By default, quantile calculation is for 0%, 25%, 50, 75, and 100%. Okay. So, for example, if you write here quantile, okay, quantile, and then write the object name data2, and then run it. So you will be getting like this. Okay. If I write quantile of data 2, okay, and I want for suppose for 10%, so I need to write 0.1, and then I want suppose 40%, so I need to write here 0.4, and I want for example 90%, so I need to write 0.9. Okay, so let us run. So I will be getting 10%, 40%, and okay. So these are the this is how we can do. Okay, these are the command for cumulative sum, cumulative maximum, cumulative minimum, and cumulative product for something. Okay, SU command you know, SEQ command you already know. That is for sequences. Okay, sequence to produce sequence. This is first starting with here and end is here and with the gap of 2. So 1, 3, 5, 7, 2. Okay, so these are the practice question I have given to you. So this SEQ along equals to data 2. Okay, suppose I have data 2, you know, you see here data 2. In data 2, we have 1, 2, 3, 4, 5, 4, 4 and 4, 8, 12, 16. We have 16. Okay, 16 entries. So if I write SEQ along equals to data 2, so it will give 1, it will count, just it will count 1 to this, 2 to this, 3 to this. It will do indexing 3, 4, 5, 6, and this will get index 16. So we will be getting a sequence kind of thing 1, 2, 3 up to 16. So you can see here the output 1, 2, 3 up to 16. The same thing, same result you will be getting if you are using SEQ of data 2. So this will produce the same sequence 1, 2, 3 up to 16. So both result are going, both commands are going to give us same result. Okay. Okay, summary command for data frames and all. Summary command, you can use summary. You can use maximum of frame, that is frame name, data frame name, minimum of data frame name, sum of data frame name, 5-number summary of data frame name. So like this, okay. So here row means if you want to calculate means of row, okay. Row sum if you want to calculate, so you can write like this. So these are the things how we can column means and row sums. These are the few things. But thing is that they are not much in your syllabus, so you need not to restudy much in deeper. Some summary, some commands like here, you should know this. What is summary command? Mean, median, maximum, standard deviation. These commands you should know, and you should study at least these things. Okay, what is apply? What is row means? What is column means? Okay, and these things are something like table. I will tell you. But these things you can skip for any these things you can leave. Attach, detach, I told you already. Okay, so these are the try it out section. You can just see and then you can practice. And most of the things I have covered, I have given it to you for practicals. Okay. So you can practice them. You will be getting know what are the things to be done. So these are the, I think this was chapter number 4 or what? Or chapter 5, chapter 4. It was chapter 4. Okay, so main thing for today's discussion is that how to have graphical representation, okay, in R. So now we know that kind of data we have. We have a data either in form of vector or matrix or data frame or list. Okay, so these are the kind of objects we can have. Okay. So now let us see how they are distributed. Okay. So I was just talking about the table. Okay, table command. So here from here we are going to see visualize the things. Which are the which we have saved in form of vector or data frame or matrix, okay, or in a list. So here data 2 is a vector, numeric vector. If I write a table and then followed by parenthesis, and in parenthesis I have written here the object name, that is data 2. So I am getting this kind of result. This kind of result I'm getting, this kind of result. So what it does mean? So here you see 2 and then we have 1 below it, 3 and then we have 3 below it, 4 we have a 2 below it. So what it is representing is that here 2 is there and 1 is written. So in this list 2 is appearing only one time. Okay, so that's why here 1. 3 is appearing 3 times. You see 3 1 place, 2 place, and then another third place 3 times. 4 appearing 2 times. Okay, and 5 appearing 4 times. You see 1, 2, 3, and 4 times like this. So what it is doing? Suppose if I want to count how many students has got 3 marks, for example, so from this table command we can easily compute, easily get to know. Okay, how many times or what is the frequency of this particular number. Okay. Okay, then we have a stem plot, stem command. So this is a stem leaf plot. This is for a stem leaf plot of data 2. So just have patience. I will tell you how it is working. Okay. So here is stem of data 2 is there. So this is by default, we are getting this kind of thing. Okay. So 2 is there, 4 is there, 6 is there, and 8 is there. Okay. So what it is doing, less than or equals to 2. How many students has got you see here 2 is there, 4 is there, 6 is there, and 8 is there. So here we got how many times a particular number is repeating. And here we are going to get the range the range just like 2 to 4, between 2 to 4, how many students has got marks between 2 to 4, between 4 to 6, between 6 to 8, like this. So 2 including 2 and less than 4. How many? Including 2 less than 4, including 2, that is 2 one time is coming. Okay, less than 4. 4 is appearing 2 times, so we are not going to include this. And 3 is less than 4 and it is appearing 3. So less equals to 2 and less than 4. How many? 4. Okay.
4.
So here 4 0. Okay, 4 0. And here you will be getting this kind of line after every stem command. The decimal point is at this vertical line. So here we have decimal point, just like 2.0, 3.0, 4.0 kind of thing. Okay, but this is for just a representation. So 2, how many? 4. 4 people have got between 2 to 4. And then here, including 4 and less than 6. Including 4 less than 6. So 2, 4, 6. How many? 6. So here 6. Okay, 6 zeros are there. And then it is just giving idea between these two, how many. So it is not telling, oh, okay, one boy got 3, another girl got 4, something like this. It is not going to tell. It will give a brief idea only. So here 6 to 8. So including 6 less than 8, including 6 less than 8. So 2 to 4. Okay, 4. And then here 8 or more. So 8 or more means what? 2. Okay, understood?
Yes, sir.
Okay.
Yes,
So
sir.
let us see if we change because you see, if I tell 2 to 4, 4 to 6, 4 to 8, 6 to 8, and I want to reduce this range. Okay, if I want to 2 to 3, 3 to 4, 4 to 5, 4 to 6, so this will be producing more accurate result. No? So here, if I write scale 2, okay, scale 2 means it will increase the number of bins. So they are called bins. Actually, 2, 4, 6, 8. They are called bins. Okay. So here we are going to increase 2, 3, 4, 5, 6, 8. Okay, up to 9. So 2, how many? 2 and less than 3. Only 1. 2 and less than 3. Only 1. And then here 3 and less than 4. 3 and less than 4. How many? 3. So like this. Fine. But when we have decimal point here, so this is the thing that need to be understood. So let us see here, because sometimes they write plot this write the output of this. They will write a vector and then they will write a stem of data 2. Then they will say write the output of this one. So you need to write like the 2 and then like this. Okay. First you can, of course, you can create table and then you can, with the help of that, you can write. Okay. So let us see it here. Okay. So here data 4 is there and this is saved in your beginning.r data file. Okay. So here this is something different. Okay. And you see when we have written here stem of data 4, so it is writing decimal point is 1 digit to the right of this vertical line. 1 digit right. It means that after 8, decimal point is after 8. Decimal point is after 8. So let us see from here. So here, if I put this vertical line here, so what we getting? What we will be getting? 21. Okay. 2 is this and 1 is this. What is this? 21. Okay. Hello.
Yes, sir.
21.
Yes, sir.
And then 21. And then if I replace this 1 by 3, so 23. 21 and 23. Okay. So 21 and 23. So you see here 21 is here and 23 is here. Both are there. 21 and 23. And then here 21 is there, and less than 21 and greater than 11 here. If we see here, decimal point is here. So what is this? 15, na? Here 11, here 0, 8 point, that is 8. Okay. So here 15 is there, and then another 15 is there, then 17 3 times is there. So you see 17 3 times, 1, 2, 3, 17 3 times. Okay. 17 3 times, and 15 2 times, 15 2 times, 15, 15, where is 15? Okay. So what it is doing, it is because this includes greater than 11 here, greater than, sorry, here in this we have yeah, 15 or less, 15 or less. Okay. So here 14.5, it is reducing it to 15. This also they are reducing it to 15 because this is 5. So they are reducing, or they are truncating it to 15. Here we have 11. So 11, 11, 12, 13, 13, 11, 11, another 11, maybe, or 10.5, maybe 11. How many places? 1, 2, 11, 11. Okay, 2, 11. Okay, only 2, 11. And then 12 is there. 12, 1, 12 is there. And then 13, 13. 13 is there. No, then 12.5. This is converting to 13, 12.5. And another 12.5, 12.5, another here. So to 12.5 has been converted to 13. Here 8, 8. Okay. So 8 is there, 8 is there, and 9, 9, 9. Okay. So 2 9s, 2 9. So like this it is converting. So basically, just like if you are to write 15, so it will write 1 and then a vertical line, then 5, then after 5. Okay. 1 vertical line and 5. Like it's writing 1 and then a vertical line and then 5. And then it will write that decimal point is right to 1 digit right to this vertical line. So it will give you what? 15, na? Hello?
Yes, sir.
So like this, it will write like this. Okay. So these are then stem plot. You can grass is nothing but you see a data frame. From data frame, it is taking one column, and then it is plotting a stem plot. So how it is working, you can read it out here. Okay. Let us see. And then the table I told you already. Then we have this histogram. So now forthcoming part is much easy. So for histogram, suppose I want to produce a histogram of this. So I want to write hist and then data 2. Histogram of data 2. Data 2 is a numeric vector. So just execute it. You will be getting the data frame. Okay. So by default, you will be getting here the title of this histogram of data 2. In the left, that is on y-axis, you will be getting frequency. And in the x-axis, you will be getting data 2, which you have plotted. Okay. But it is necessary to rename it x-axis, y-axis, that is their labels we can change, and also we can change this title. Okay, so that we will see. It is easy, and this is common for all kind of graph we are going to. Okay, we are going to see further. Here you see, if you see in plot. So in this plot, if we are getting break at 2, at 3, 4, 5, 6, 7, every integer point. Suppose I don't want break here at 3, I want to break 2 and 4 and then 6 and then 8 and then at 9. So for that, we can use this kind of command, breaks, and the point we can write. Suppose I want to break like this. So let us run. Just a minute. Yeah, just a minute. 2, 3. Okay, you see. 2, 3, 4, 5, 6, 7, 8, 9. Okay. So here we have breaks. Suppose I want to remove this. I don't want break at 3. So you see 2, there is no break at 3, 2 to 4, and then 4 to 5. If you want to remove this 6, you can remove it also. So here, okay. So we can manage this break also. And color as well. Okay. So this is how they have inserted break at 2, 4, 5, 6, and 9. So this is light gray color. We can change the color. For this, let us see these commands. To change the color, we need to write color, COL equals to color name in quotes. And then main, this will give the title. Like here, this title, okay, main equals to, then in quotes we should write X label, label of X, Y label, label of Y, and X limit and Y limit. X limit, that is, this is a limit from here, for it is 0 to 9. And Y limit is from, they are writing density kind of density here. So they are not given, they have, this is, in this graph, it is taking default, okay. So X limit, Y limit, we can change the X label and Y label and the title of this graph. Okay. So this can be done like here. Here we have, let me, you see, histogram of data to breaks as per our choice. Then put comma and then just a minute, what happened? I think here you see histogram of data to color. I want to gray 75. This is 75, 80 something. They are intensity. If you want red, you can red. If you want green, you can write green. If you want black, you can write black. Okay. If you want blue, you can write here blue. Okay. And then main null. Main null means that is no title. Okay. You see here main equals to title. So I want to produce some title. So let me write here. We'll write some title here. So what title is to okay of data. Okay, like this I have changed it. Okay, and then I can write here X label size of class for data 2 I've written. Okay, then Y limit I can write 0 to 0.3, and then frequency is false. Frequency is false means frequency is false means frequency is false means we don't get frequency kind of thing here. Okay, but earlier it used to write. Okay, let me show you here. Earlier this is a density frequency here frequency. So we are not going to get frequency, okay, because we set it as false. So let us run it. You see the graph. Okay, you can give the different color. Okay, you can give the different color to each strips. here. Fine. You see size of class data 2 now it is coming different. It is coming different. Okay, and you can this in place of density you can write also some another y label. Okay, y label is not written, so we can write y lab equals to in quotes labels. For example, I'm just writing it to show you. So you see it has been changed y label. Okay, like this. Clear? So these are the commands. They will be common in every kind of graph we are going to see hereafter. Okay. So let us see some more thing in detail in chapter number 7. Introduction to graphical analysis. In this we see that Box-whisker plot, scattered plot, line, pie, and bar chart. Okay, so let us see them one by one. So box plot, basic box plot. FW is a data frame, you know, and you know these are the things which are saved in FW. And you know also that you need to fetch some column by putting $ after the data frame name. So if I want to make a box plot for this FW, this column of speed column of FW. So we need to simply write like this, okay? Or we say like box plot if you want for data 2. So let us see. So for this you will be also getting, because in FW also we have a numeric vector box plot. Okay, box plot of in FW we need to extract, for example, speed. So this will give us the box plot. Okay. So here you see this color is light gray, and there we are seeing that a thick line in between somewhere, and this thick line denotes what? You know, median. No? This denotes median. Okay, this thick line. Okay, basic box plot we have seen. So this is single. If I want to two parallel or two box plus together, plot together, so we can write FW count and as well as speed, or two vectors here. So we will be getting like this. Okay, this is for 1, this is for 2. Same thing what we have done with the histogram, we can write name of this plot here above this graph, above this plot. So you see next here box plot of these count vector and speed vector. Okay, so here if you see there is single box plot, then you won't be getting anything here in below this. But if there are 2 or 3 or more, so you will be getting some number 1, 2, 3, 4, 5 like this. Okay. So, but you want to give here their name, particular name, just like the first one is for count, second one is for speed. So we need to write names equals to C equals to count in quotes and speed in quotes. So this will produce here count, here speed. Okay. And then a title, it is writing X label and Y label. This you can do together this command also. Okay, let me show you. Let me see. Here we have a box plot of FW and count and speed. So here count and speed we will be getting. Let us remove this. Okay, first let us see the output of this. So here we have 2. Okay, so once we have these things, let me put here. So I want X label, so I can write here X label also right here. Let me write count and speed. So for your desire, you can write, you see X level, count and speed. In Y level, you can write write y label, and in quotes you can write value or something. Let me write value. Okay, value. So let us run. You see value. If you want to give the name of this chart, some name. Okay, so let us write here box plot of count and speed. So run it. You see everything is coming. If you want to give color, so COL equals to COL equals to in quotes. Let us write red and then run. So both are red. Okay. All right. Hello.
Yes, sir.
And if you want to give a different color, so similarly, what we have done, what we have seen here, color, you can create a vector and then you can give color, distinct color to them. Okay, you can try it out. Like here, they have given color. So they are writing, actually, they have they have written two line commands, these commands in 2 lines. So they need to run first this one and then this one, or they can run together, these two. But I told you we can write in one command also here. Names, count, speed, like this. Okay. So if you want to give color, so we can write echo COL equals to then C and then red and like this. Let us see if it is working or not. Color and then C, let us write here red. And then another color, what color we can write? Suppose we are writing green. Okay, and then run. It's okay, it is running or not. Yeah, you see. So one is red, another is green. You can produce like this. Fine. Okay.
Yes, sir.
So let us. So these commands attributes now they will be common in every graph. So let us move further. Okay. So this I told you this already. X title, Y title, and all. So horizontal box plot. This is vertical. This is vertical. And if you want to make them horizontal, you need to write just simply for this command. Let us write here, then here horizontal equals to true. Okay. So once you write, you will be getting horizontal. Okay. One more thing I want to tell you, if you want to export it, you can go here in export button. You can save it as PDF or a image. So you can from here you can choose the directory. If you want to desktop, you can save desktop on desktop and all. And then here you can give the name. Okay. And there are so many format: PNG, JPG, TIFF, BMP, SVG, EPS, so many things. And even you can select the size also from here. Okay. Fine.
Yes, sir.
So here you are getting this kind of plot in the exercise problem I have given. You need to just save it, and then in the Word file, one Word file you have to paste after the command. Fine. So let us go further. So these are the things I think these I have given to you. So there are 3 box plot. So already I told you. Okay. Then we have a scattered plot. Scattered plot. This is this kind. The plot we have done earlier in our early classes, like in 11th, 12th, or earlier classes, we used to plot some on graph paper. So we have been given X, then we used to calculate Y, and then we used to plot. So this is like similar to that. So if we have F of XY, okay, XY. So we will be getting 2 things: speed and count. Okay. Either we can use this dollar sign, or we can use with, if we are using this what we call data frame. Okay, or we can attach and deattach if I don't want to use this command. So they are alternative command to each other. Okay, either I can write this, or I can write like this, or I can write this. Fine. So here, plot, simply we need to write plot, and then two things. This is speed, this is count, and then X label, Y label, all you know. No? This is all you know. Beautification for this. So let us see. You see, some dots are coming. So there are something, this is 5, and some, I think 15, 5,15, something like this. So they are plotting. So here by default, you will be getting this circle, but you can change them. Okay. And on X-axis, Y-axis, you will be getting here, you are getting, because they have written here, Y label, X label. Otherwise, you will be getting this FW speed and FW count, whatever you have written here in that order. Okay. So you can change it, X label, Y label, plotting symbol. So plot symbol, there are some new thing you can you will be learning here. Like earlier you got just like circle like this. Okay, so there are 26 kind of shapes you can use. So they are called plotting character, and they are referred as PCH equals to instruction. Okay, PCH equals to instruction. In instruction you can write number from between 0 to 25, including 0 and 25. Okay, like here, plot. They are creating a vector here, 0 to 25. How many? 26. No, this will create a vector.
Yes, sir.
0 colon 20, 0 colon 25. Okay, so you will be getting, you see, 0 to 25. That is, this will be a vector of 26 entries. Okay, and then this will repeat 1 to 26 times. Now, then plot character, this PCS, this is plot character 0 to colon 25. That is, they are going to use everything from here. First this, second this, fourth this. Okay, and then CEX. CEX means character expansion. That is, आप इसका साइज कितना बड़ा छोटा चाह रहे हो, समझ रहे हो आप? ये जो कैरेक्टर सिंबल आएंगे ना, जैसे ये यहाँ पे था इसका, so how much is big size you want, how big size you want. So this is decided by this CEX. CEX is character expansion, PCH is plot character. Okay, so this will plot, this will give you some a plot for you. Or in this plot, let we have this now. So let me write here also. Just a minute. PCH plot character. So I want to, suppose I want to 3. I want to write 3. So you see plus. In third place you will be getting plus. You see 3 is for plus na. If you write 4, you will be getting cross. If you write 5, you will be getting this diamond shape. If you want to write here, if you write here 5, then you will be getting a diamond shape. Okay, and if you want to enhance it, so you CEX, that is plot expansion, and plot expansion you can write like here they have written 2, that is 2 times. Okay, if you want to write it like 2 times, so it will enhance. You see, if you want to write 3 times, it will enhance. If you want to 4 times, it will another enhance like this. Okay, got it?
Yes, sir.
So setting X limit and Y limit. So this I told you already know, na? X limit, Y limit. While you were using histogram. So you can set X limit and Y limit also. So here X limit 0 to 50, you see. X limit 0 to 50, they have created it. And Y limit 0 to 50, another. vector 0 to 50. Earlier, what we have seen here, 0 to 35 was there by default, and this was 0 to 40. Okay. So let us move further. And now they are writing best fit to scattered plot. Best fit to scattered plot. So this is linear modeling, actually. So for this, they are using this command count speed and okay. I think I have told you this. No? Okay, limit I covered already. Okay. Here we have some scattered plot, some plot points. We are only seeing point. Okay. So, but we need to see whether which line will be fitting, straight line will be fitting in this graph. So some straight line will be either from 0, either from 5, going. Okay. So for that, we need to write, we need to use these commands. Okay. Like count speed, that is y equals to fx we used to write now. So y is dependent and x is independent. So here speed is independent and count is dependent. And LM, that is linear modeling, that is we are going to fit a linear plot and AB line will plot. Okay, pass it on it, slope with intercept. Okay. And here we are using data equals to FW. So this can be done like let me tell you. So for this, you have already plot. We have already this plot. So let me show you. So you are going to get this line. But thing is that if you don't want to use this FW data, because sometimes they are not easy to remember, so you can write like this FW, and then dollar. And this you are familiar with this. So you will be getting the same thing. Okay. So here, this is the line best fit line in it. So this command you need to remember. Okay. First you have to plot, and then after plotting, you have plotted this FW, this speed and count. Okay. Same thing you have to write here, count in and tilde, and then another sorry, count and speed. So here the order you see, this is x, this is y. Okay. So when we write function, what we write? Y equals to fx. So this count will be coming first, and this will be after that. Okay. So this is a linear modeling, linear plot, and this will provide a slope and all. Okay. We need not to go in detail for this, but this line is sufficient if they are they want, and you need to just draw this is scattered plot, and then you need to write it like this. Okay, but remember the rule of this. You have to change them, these rule of them. Okay, you have to write this this first and this second. Okay, and they are optional: X label, Y label, and color. Okay. So one thing, you see this line is a straight line. If you want to make it dotted or something, so you can write because they are, you see, these diamonds are plot character, but this is a straight line. Okay, so this line can be dotted or dot, or this can be hyphened. So many options are there. So here you see this line is style 0, 1, 2, 3, 4. What if you write 0, then blank? Then if I write 1, then it is default solid line you will be getting. If you want 2, then you will be getting dashed. And how it is produced? You here there are something LTY, that is line type. You have to write this. Okay, dotted. LWD, line width. Okay, 2, and color gray 50. They have written here. Okay, so line 2 dotted. So let us see your line type LTY. They have written LTY line type LTY equals to if I write here 2. Oh, sorry, this is numeric number. I need to write here number. I don't know whether able to see or not. 2. Okay, 2-6. Let me write here 6. Line type 6. Line. Actually, it is changing, but maybe let me save. It is only showing solid, I think. It is not changing. Just a minute. What happened? Let me run together. Everything together. Oh, something. Okay. You see, dotted is coming. You see, double dot is coming now. Double dot is coming. So in this way, you can change. Either you can write dotted, like the way they have written. The way they have written. Or like here, dotted, they have written. So if you are writing these in a character, then you need to write in them in quotes. Otherwise, numbers you can write directly. Okay, this is line width, just like plot character you were enhancing by CEX expansion, character expansion, like this. Also, you can line width, you can write here. Okay, and then color you can very much give it. So, okay, so this is done. So we have done a scattered plot. Now next pair plot. In pair, just like we have seen here, of course, this is also a kind of pair plot. Okay, XY we are plotting. But here we have another, we have just used plot command to produce a scattered plot. Okay, but if you have 2 column data here, so if you write here plot equals to FW, so we can get like this a plot instead of writing like that. Okay. But you see, if you have so many data, then it is a problem. Okay. So what we can write pairs. Okay. X plus Y plus Z equals to data equals to our data. What they are doing, this our data is their data frame or something. Okay. So that's why they are writing. Otherwise, you can write here, suppose, for example, this MF is a data frame. So you need to write MF, then dollar, then length, then comma, then MF dollar is speed. Okay, and then you can write this command. Let me tell you here, just like this. You run this one, then because XYZ is not there. So here FW, either you can attach them to use them directly. So here FW and then not FW. What was there? What was the name of this? MF, no? MF. Okay. MF. MF, then dollar, then suppose length, and then plus you write MF, then dollar, then suppose speed, then Z, MF, then dollar, then suppose NO3. Okay. So in that case, you can remove this. And then you can plot. Error in you plot figure margin too large. Okay, so there is no such error, but thing is that margin that is sufficient space was not there. You see. Okay, so this is the pair plot. Pairs you can use pair command. And other things you just like here circle is there, you can change them. Just like we have done earlier. Plot character, color. Okay. Plot character, they are using X. So they will be getting X instead of this circle. Or you can use a number between 0 to 25. Another plot is line chart. Line chart. So what kind of line this point only, this line segment between these two L, if you are writing line segment alone with no points, there will be no point, only line. Okay, line over plotted with points, that is line भी रहेगी और points भी रहेंगे, ठीक है ना? So इस तरीके से कह के, okay. So for here line chart, only this simple command, just like plot we have done earlier. So the same command will work here, but here we are not going to use any pair kind of thing. That is x comma y kind of thing. Nile is a Nile was a river for which they have saved the data in beginning.r data. Okay, so this is the line chart. L means there is no, you will be getting only line without points. Okay, without corner points. And if you want B or if you want to O, okay. So if you change it here O, so you will be getting points also. And then you can change the color and all. So this is done. You need not to worry about this line chart, categorical or non-categorical data. Leave it. Then pie chart we have. So for data 11, we have data 11 here. Data 11. Then run it. You see numeric vector is there. Okay. Then you write pi. And then pie chart of data 11. You see. So they are taking, it is automatically taking colors, giving them different colors. Okay. And then numbers also. Now we need to customize the color and boundary and this number 1, 2, 3, 4, everything we can customize. Okay. So how many 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 entries are there in data 11. So in data 8, we have a month, 12 month from Jan to December. So I want pie chart of data 11, and we can use these entries, okay, from January to December as labels. So instead of getting this 1, 2, 3, 4, 5, we will be getting names of month. Okay, so like here write labels. Okay, equals to what was data 8 or what data 8, I think. Okay, you see, so data 8 is there. Now I want to give the color, so I can give color also. You see different color. Okay, so if I want to give color, so let us give color COL equals to C, and then we can write in quotes, suppose red. Okay, then gray. Okay, if I give two colors, then it will automatically repeat it. Okay, if I give suppose another color, blue, so it will repeat 3 color. First, it will start from January, then red, and then after then Feb, gray, and then blue. Then फिर red, gray, blue, red, gray, blue. Okay. Another color, suppose I'm giving yellow. So another color will come. So 4 will repeat. Okay. Time again and again. If you want to give color pink, so you will be getting another color. Okay. So like this. Fine. So they have given it another way. They have created this vector and then they have put it color equals to BC. Similar, you want to color it to give it to clockwise, anti-clockwise, so you can customize it also. And the saving it is simple as we have done earlier. You can save it. All right. Okay. So here you see this is a matrix, but this is a matrix. So they are fetching or they are extracting bird And then all row first column, that is for garden, they are plotting it. For garden, they are plotting. So you have these pie plots, pie chart. Okay. Next, we have a Cleveland dot chart. This is produced by dot chart equals to, dot chart and then followed by data name in parenthesis. Okay. You see data 11, you know data 11, data 8 also you know, but we don't know output as of now. So let us see what is the output here. So this is a dot chart kind of thing you will be getting. Okay, but some line we will be getting. Okay, in between. Okay, so these things only we need to learn. Dot chart. Okay, so there are so many customization, but we need not to worry about this. Color name, you know, that is L color, that is a color used for lines. These lines are there, no? These lines, they can be customized. These plot character can be customized. Their expansion, you know, CEX you will have to write for this. Okay, X label and Y label, X limit, VG color, that is background color you can set. Okay, so if you want to set background color, so you have to here BG. Okay, BG. BG equals okay. Background color, and then in quotes, you want to, you can give any color. Okay. Yellow, this background color to these. Okay, for this plot character. So different things are there. This is background color. L color is specify the line color. Okay, L color if you write. We're getting red line color. Fine. And C color, this color give the group label and group data points if it's specified. Color is specified color used for plotted points and main labels. So these are the things you can, something you can learn always. Okay. So I think this was the last plot. No, bar chart is also there. So bar chart you can produce simply by bar plot. Ren is already saved data here. And you see, so in every month there are some data. For example, suppose these figures denotes the rain in millimeter. Okay, in every month. So we can write. Okay, we can write a bar plot, and in parenthesis we need to write rain or whatever data we want plot. Okay, so I want plot data 1, data 11. So we can also get plot for data 11. But this is a non-categorical data. Rain is categorical data. Categorical data means you will be getting this variable as well as the associated numbers also, associated figures also. Okay, so this is non-categorical data. In between, we have seen here. Okay, then X label, Y label, everything you can and color you can give just like we have done earlier. Okay. So with this, I think we are done. There are saving graphics and all. I told you how we can save. No? How we can save, I told you. Bar chart, yeah, bar chart is also there. I think, yeah, bar chart. So this is a bar chart. Let me tell you. What we were doing? No, bar plot, yeah. We were discussing bar plot only. So we can horizontal, if you write, if you want to horizontal, this is vertical bar plot. If you want horizontal, you can just write horizontal equals to true. Okay, legend, okay. Legend you can also produce legend equals to true, you will be getting legend. Here in bar plot, we have not given any color here actually. So you see here, legend is coming. What we have done, bar plot for birds. beside true. Beside means one by one, side by side you will be getting 1, 2, 3. No, side by side you will be getting for each data. Okay, in word. Okay, beside true, legend true. So you will be getting legend this automatically. It will give color and then legend also. This dark is for blackbird. This is another. This is another. Okay. So and then title, you can write this command in one line instead of two lines. And if you want them to produce in horizontal, so you need to write HORIZ equals to true, or you can write complete horizontal equals to T or true. Okay, so you will be getting horizontal data, like horizontal bar chart like this. Fine. I think now you can do. And these are the commands for summary of commands.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.